I want today to talk about descriptive statistics. For quantitative variables. Typically, those descriptive statistics for quantitative variables, remember that they are the numbers that describe the data. And one thing I want to make sure my students feel comfortable with is that when you just see these numbers, you can make some kind of conclusion about an entire data set based on maybe 3 to 5 numbers. And that's a skill that can be really useful in your professional life. So the ones that we always use is X bar. I'll give you those definitions. X tilde, something we call the mode, which poor mode gets no fancy symbol. And then we typically have the quartile 1 and the quartile 3. Those are Q's. It's a little hard to tell. And so these 5 really can give you a super good idea about the data. I'm going to give you their definitions. The definition of X bar happens to be, in English, the average value. In math, it's what you think it is. You add up all the values and divide by how many you have. We simplify that process by saying the sum of all the data values divided by how many data values you have. So the average value is the same average you've been computing your whole life. So the median is a little more complicated. First off, the data needs to be in rank order first before you can find the median by hand. If you're using a computer, it will do that all in its own special computer brain and pop out the median. But you have to have it in rank order if you do it by hand. And it is defined in English as the data point where 50% of the data lies below. So it truly is the middle of the data. There's some things that need to be worked on in the median, which we will work on. The mode is, of course, the what we call the most frequent number in the data. Sometimes data has no mode because every data point is unique. Some have modes, some don't. Quartile 1 is very much related to the median, the quartiles. Those 3 things I just dotted, they're typically related to each other because quartile 1 is 25% of the data lies below. Below. And quartile 3 is where 75% of the data. And in order to find these, it can be somewhat time consuming, but it's not typically difficult. So what I want to do is give a data set, and then we will compute these different values for a data set. So let me switch it over here. And I want to give you data of number of hours students studied. Okay, so here's my data, and it is, and I'm just going to immediately give it in order. Okay, so there's 3 students who decided not to study at all. a student who studied 1.3 hours, 1.4, 2.5, 2.6, 2.8, 3.2, 3.3, 3.8, 4.8, and then the big studier of the group, 5.2 hours. Okay, so if we calculate the mean, x bar, right, what we do is we take the sum of all the data points and divide by how many we have. So we add up 0 plus 0 plus 0 plus 1.3 plus 1.4 plus 2.5 plus 2.6, and we divide by how many data points we have. 13 data points. So we'll add all those data points and divide by 13, and when you do that you should get 2.2. So I want you to verify that on your own right now while you're listening to this lecture. The mode, which data point happens most often? Well, it's the 0. And you can see that the most frequent number in the data set is 0. More students didn't study at all than did study, is one way to think about it. The median, okay, what we do is we find the middle. So you kind of cancel them out. So 0 and 5.2, 0 and 4.8, 0 and 3.8, 1.3 and 3.3, 1.4 and 3.2, 2.5 and 2.8. So it looks like 2.6. Now here's a note. If n is even, then the middle equals the median. If n is, I just said that backwards. I'm sorry about that. If n is odd, just like we had here, we had a 13, n was odd, so we chose the middle. If n is even, then the average of the two middle equals the median. So you want to make sure that you know if you have an even number of data points or an odd number of data points. The quartiles, they're a little bit not difficult to do, but they require a little bit of formula. Okay, so quartile 1, again, is where 50% of the data, or 25% of the data lies below, and we calculate that by we take 0.25, so 25%, times how many data points you have plus 1. Okay, and this is where it's really weird, in that the quartiles mark the location in the data set, not the actual data point. So if I compute this and do 0.25 times basically 14, right? 13 plus 1. And I make that computation so I know what I get there. So I'm doing a little computation while you catch up. I get 3.5. Okay, now be very careful. 3.5 is not the quartile, it's a position. This is a position in the data set, all those I characteristics. So that position, you're going to round it like you always round. So it rounds to 4. So I go to my data set and I go 1, 2, 3, 4. And this is the 4th data point. So the actual quartile is 1.3. You have to be very careful. 1.3 is the answer. 4 is the position in the data set in rank order. So that's another reason why it's nice to have things in rank order. If we do quartile 3, that is given as the formula of 0.75 times n plus 1, and that is 0.75 times 14. And if we make that computation of what 0.75 times 14 is, so we're taking the 75th percent of the 14 data points, and that gives us 10.5. Okay, again, this is a position. In the rank order. So we always take that and round up, or you round using however you round, the rules of rounding. So since it's 0.5, we round up and we get to 11. If we go back to the kind of previous screen, if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, this is the 11th data set. Or sorry, the 11th data point. So our position was 11, but our data set, our actual data point, is 3.8. And that's the data point. So if we give what we call, and we do this a lot, the summary statistics. The summary statistics, we have X bar, the median. Sometimes we do the quartiles all together because the median, the quartile, and quartile 1 and quartile 3, they tend to go together since they're marking the percentages inside the kind of the data set, and then we have the mode. So we would report all those. We would say that the mean is 2.2, that the median is 2.6, quartile 1 happens to be, I just have to refer to it, 1.3, and quartile 3 happens to be 3.8. The mode was 0. So from these numbers, we can get somewhat of an idea, and we'll do more work with that on how to get more information just from these summary statistics as we move along in the course. On a second note, I want to talk a little bit about percentiles. Because percentiles, everyone hears that you're in the 80th percentile. So if you're in the 80th percentile, that means 80% of the data ,80% of the score is 80% of the data is below that score. So if you want to compute a percentile, as this example, you would take 0.80 times how many data points you have, 0.8 times 14, and what you can see is this is 11.2, which again rounds to the 11th position. And that 11th position in our data set, the 11th position is also 3.8. So what does that mean? It means that the percentiles, it says that the quartile 3 and the 80th percentile are the same number, which doesn't make any sense. So percentiles are not so useful in small data sets. So we're going to use them in big ones. We will continue to talk about percentiles as we move forward.